Welcome back, everyone. I hope everyone has tried these 4 problems and that you have your work in front of you, because what we're going to do in this video is go over the answers to these 4 calculations with regards to the rules for significant figures. How to do the calculations and how to apply those rules for the final answer. So in this first problem, we have subtraction. If you remember, the rule for subtraction is we care about number of significant figures after the decimal point. What makes this problem a little bit trickier is that one of the numbers that we have subtracted is in scientific notation and the other one isn't. So just to practice, let's go ahead and, let me get my pointer. Let's go ahead and put this number, the second number, in scientific notation. Then we can easily line up the numbers and see how many sig figs we should have in our final answer. So let's take this 1913.0. Let's put it in scientific notation to get it in the same form as this one. So this decimal place needs to be moved in between the 1 and the 9. So 1, 2, 3. It needs to be moved 3 places to the left. So my answer for that part of the problem is 1.913 times 10 to the 3. I'm going to be subtracting 4.6 from that. I'm just going to write that up here so you can clearly see, since my 10 to the 3 powers are the same, I'm subtracting. This has 1 digit after the decimal. This has another. So my final answer needs to have 1 sig fig after the decimal as long as I write it as a times 10 to the 3. So when you put this in your calculator, 4.6 times 10 to the 3 minus 1.913 times 10 to the 3, you should get this number that comes out of your calculator. But that does not have the correct, that's what comes out of your calculator, but that does not have the correct number of significant figures. Our answer needs to have 1 digit after the decimal, as long as we write it as 10 to the 3. So if we were to write this number as a times 10 to the 3, that implied decimal is by the 7. So we move it 1, 2, 3 places to the left. So writing this number in scientific notation, along with rounding, is going to be 2 point, and that digit is significant, but I need to look next door to see if I round up or not. If that digit is 5 or above, then you round up. If it's 4 or below, you round down, or you don't round at all. In this case, since it is an 8, that 6 becomes a 7. So my answer is going to be 2.7 times 10 to the 3. So that is the answer for this first problem. And I actually think that first problem is a little bit tricky because you needed to make sure you had it in scientific notation and remember the rounding rules. Second one isn't as difficult. We're just dividing, and we've got both numbers in scientific notation. Since we're dividing, the rules for division care about total number of sig figs for your answer. This first number has a total of 3 sig figs. The second one has 2, so my final answer should only have 2 sig figs. So 2.5 times 10 to the negative 83. Now let's look at this third problem. We've got multiplication and division. So kind of double trouble here. So here's where remembering not only the significant figure rules, but remembering your order of operations is going to be important as well. And that order of operations is you always do what's in parentheses first. So when you put these first 3 numbers in your calculator, multiplied, what spits out of your calculator is this. When you do the second 3, or when you do the second set of numbers, what spits out of your calculator is this. Now we need to remember the number of sig figs for each, because that's going to affect my final operation, the division, and how many digits I report. You do not want to round in between. You want to carry all of those digits along with you when doing the math, but you do need to make some sort of note to yourself as to how many total sig figs that intermediate answer has. When multiplying these first three numbers, they all have a total of 3 sig figs, so my answer should only have 3 sig figs. So that 5.232 is not significant. It does not speak to the level of precision of the measurement. Don't want to drop it. I just want to make a note to myself that I've got only a total of 3 sig figs for that part of the answer. For this part of the answer, well, I've got a total of 4 sig figs for this. Only 2 sig figs for this part of the problem. Remember, these zeros are not significant. They are to the left of the first non-zero number, so they are not significant. They don't speak to the precision of the measurement. 99, that has 2 sig figs. So my final answer, at least that I report from that part, only has 2 sig figs, the 1 and the 9. The 2, 9, 0, and 5 are not significant. So I'm just going to make a note to myself that those digits, I should not drop them, but they are not significant. Now I'm going to go in my calculator and divide these two. 2225.232 divide by 19.29015. When I do that division, the number that I get is this. But I can't report all those digits, right? I have to remember the number of sig figs from my intermediate step. This had a total of 3 sig figs. This had a total of 2. So I can only report 2 significant figures for this answer. It shouldn't just be 11 or 12. I need to round. So my answer is going to be the 1. And then this number gets rounded because the number that it is next to, the first number that is not significant, is 5 or greater. So it gets rounded up to a 2 and becomes a placeholder. If you would prefer, write it in scientific notation. And I love scientific notation because you can easily tell from that number, oh, that number has a total of 2 significant figures. And that's what I needed because of the significant figure rules for multiplication and division. So that is the I would accept either of these answers, but your final answer is 120 or 1.2 times 10 to the 2. Now let's end this practice with doing some division, multiplication, and addition. Once again, we need to do things that are in parentheses first, and we need to do that inner parentheses first. When I add those two numbers, this is what I get. I need to remember, though, that that 6 is not significant. Remember, I care about number of sig figs after the decimal. This has 3. This has 4. So my answer should only have a total of 3 sig figs after the decimal. I'm not going to drop that 6 yet. I'm not going to round. But I just need to keep that in mind for doing the other parts of the problem. Now I'm going to go ahead and multiply it by, I'm going to multiply that answer by 15.3. And when I do that, this is the number that should spit out of your calculator. I need to remember the rules for multiplication now. We care about total number of sig figs. 15.3 has 3. We said this has a total number of 3 sig figs. So my final answer, at least with just the parentheses part, has 3 sig figs. So that 8258, I'm not going to drop it just yet. I round at the end, but I need to remind myself, oh, those are not significant. Just the 10.3 is. Now I'm finally going to divide by the 1.2, which has a grand total of 2 sig figs. when I do that division, when I divide 10.38258 by 1.2, this is what should spit out of your calculator. But how many sig figs should I report? Well, the 1.2 has a total of 2 sig figs. We said that this intermediate step, or this step, had a total of 3 sig figs. So I should only report 2 significant figures for my final answer. And with rounding, that should give you a final answer of 8.7. So I think those are some good representative examples for using significant figures and rounding in calculations. We'll certainly do more in class and in recitation. In the next video, we're going to start to talk about dimensional analysis and SI prefixes.